Hello everyone. Within today's video, we'll focus on our non-CMT HMIs. In the beginning, we'll discuss how to get started with EasyBuilder Pro. Once we're well acquainted with the basics of our software, we'll demonstrate a few tips that will help enhance your project. Before we begin, I'd like to note that if you're looking for specific information, you can find quick links to different topics within this video in the description below. Now, let's get started. Weintek has produced several different groups of HMIs. These groups, which we refer to as series, currently consist of our CMTX and CMT series, IE and IER series, IP and XE series, and we also have our MTV and eMT series. The term non-CMT refers to any HMI not within our CMT or CMTX series. Non-CMTs are designed without many of the IIoT solutions that come standard with our CMT series. But that doesn't mean that they're any less capable. Now, if you haven't already, please visit our website, weintechusa.com. Create an account, and then download the latest version of EasyBuilder Pro. Once the application is installed, we'll go ahead and open EasyBuilder Pro. Within our application, we'll select our HMI. In this example, I'll select an MT8073IE. And as in our previous videos, I'm going to keep Use Template selected. Use Template will generate some system windows, keypads, and some additional windows that will help us build our project. With my HMI selected, I'll click OK on the bottom right. As our application opens, you'll notice our system parameters open as well. Now, the configuration of our system parameters is very important within our project. Our Device tab, for example, is where you can define an external device that will be used within your project. To do this, simply select the New Device/Server button, and at the top of the following menu, you can name your device, as well as let our HMI know if this device is a secondary remote HMI or a PLC. Towards the center, you'll find our device type. Selecting the device listed will reveal a menu in which I can search for the external device that I'll be using within my project. In this example, I'll search for an IDEC FC6A, and I'll select this driver and click OK. Underneath our device list, we'll find a second drop-down list labeled I/F, meaning interface. Depending on the HMI and PLC you have selected, there are several different ways to interface with your device. The FC6A will allow us to communicate via Ethernet or serial. And next to this, you'll notice a hyperlink that says Open Device Connection Guide. Now, our support team always recommends that you check the specific guide created for your external device. Selecting our hyperlink will open a default guide that will provide step-by-step instructions on how to add an offline copy of our PLC connection guide to your PC. And at the bottom, you'll also find a direct link to access our PLC connection guide from our website. To demonstrate this, I'll select this link, and we'll select the manufacturer, which in this case is IDEC. The model is the FC6A, and our driver is listed as IDEC MicroSmart FC6A series. And I'll select the following PDF, which will open in a new tab. Within this PDF, we'll find specific information that will help us connect our HMI to the IDEC. Although connection between the FC6A and our MT8073 is fairly straightforward, this is not always the case, and in some situations it is not only recommended but necessary to follow the specific instructions listed within our guide. Let's go ahead and close our connection guide and take a look at our communication settings. To connect with the FC6A, we can choose between a serial or Ethernet interface. And in the section below, we can define the IP or COM settings. Now, establishing communication between the HMI and a non-tag-based PLC is fairly simple. And as you'll see in a second, configuring our device to communicate with a tag-based PLC is just as easy. In this example, I'll go ahead and select a compact Logix, and our interface should automatically be sent to Ethernet. Before I proceed, I'm going to select Open Device Connection Guide. And as I mentioned before, there are some devices that have fairly specific instructions on how to establish communication. Our device connection guide for the compact Logix really illustrates this point. As you'll notice, our connection guide has step-by-step instructions that explain how to import tags. I'll close our connection guide and we'll proceed to import our tags. I'm going to leave the IP of our device at its default setting and click OK to close our device settings menu. Just under our device list, we have two different methods that will allow us to import tags. We can use our Import Tags button, which will, in this case, allow us to select either a CSV or L5X file for import. The alternative is to use our Get Tag Info button, which will allow EasyBuilder Pro to retrieve tag data directly from the PLC. Since I have a CSV file, I'll go ahead and demonstrate this process. I'll select it, and click Open, and I'll get the message here that our tags have imported successfully. Clicking OK, our tag dialog will display. Within this menu, we can see what tags we've imported into our project. And with our communication properly configured, I'll close this menu and we'll move forward and start building our project. The default startup window, which by the way can also be configured within our system parameters, is window 10. And our work area, or the area that will be displayed, is this purple box in the center. One thing that's really nice about EasyBuilder Pro is that Weintek has placed a huge focus on making our software very intuitive and easy to use. We have 5 main tabs related to project development. The Home tab is where we can find our system parameters to establish communication. Our Project tab is where you can create custom tags for your non-tag-based PLC if you would like to do so. The Object tab is where you'll find the objects used to control or monitor your device. The Data/History tab will allow you to perform data logging or create alarms for your device. And the IIoT tab is where you can define an MQTT server. That is, unless your device is an IP model which does not support MQTT functionality. And of course, these tabs serve other functions as well, but because some of you might still be learning, I want to make sure that the basics are covered first before we move on to more advanced examples. Let's go ahead and create our first object. To do this, we'll open our Object tab, and I'll go ahead and create a bit lamp. The device addressing by default has the compact Logix selected. As a demonstration, I'll go ahead and select one of our PLC tags. The project currently has only one bool tag imported, so we don't have many choices here, but if I had a giant list, I could easily search for the tag I'm looking for within our search bar, or search through our structure list on the left-hand side. I'll go ahead and select the On/Off tag. And our bit lamp is now configured to represent data from this read address. Sometimes it might also be necessary to monitor or use the HMI's internal registry. Or if you're using multiple devices within your project, read an address from a different device. To do this, simply select the device drop-down list then select Local HMI, and you'll notice that we can now access and monitor any one of the HMI's internal bit registers within our bit lamp. Let's go ahead and leave our address as LB0, click OK, and place this object on our work area. Now I'm going to select another object. This time, I'll select a toggle switch, and we'll configure the device address for our toggle switch to LB0. And let's take a look at our attribute section. Within this section, we have a few different configurations. We can use this to set our bit either on or off, toggle between the two, or use a configuration called momentary. I'll select momentary, and what this means is that our toggle switch is going to switch to state 1 as long as we press and hold our button. And when we let go, the toggle switch will revert back to state 0. This time, let's go ahead and select our Shape tab as well. By default, our toggle switch uses a 2-state image of a blue switch. By selecting either a 1 or 0, we can alternate this image to view both states. Certain system images, such as this, also allow us to change the color depending on the object state. For example, I can select red on state 0. And if we flip to state 1, you'll see it's still blue. As is often the case, this image might not correlate with other graphics within your project. Thankfully, EasyBuilder Pro has an extensive collection of image libraries. To access this within a particular object, we'll go ahead and select Picture Library within our Shape tab. We have 2 tabs within our library. The Project tab will allow you to store up to 1,000 images within your project file, and the Library tab contains all of the system images that you might use for bit lamps, input objects, or just as a static picture within your project. I'll go ahead and select our library section. In our drop-down menu, I'll select a new library to reference. In this example, I'll select the Control Panel section, and within the sub-menu, I'll select Toggle Switch. And I have some nice graphics to choose from. Let's go ahead and select one, and then we'll click OK. Alright, now we have our new image, and so I'll click OK and place our toggle switch. Now that we have some basic experience on how to create an object, let's take a look at one of the most advanced objects within EasyBuilder Pro, the combo button. The combo button is used to perform a list of sequential actions. Clicking the green plus sign, we can start adding to our list. I'll go ahead and choose Set Bit from our action list, and we'll set our LB0 bit on. Next, I'll add a delay to our list, and I'll give us a 1000 millisecond or 1 second delay. And we'll add another set bit to turn our bit off. While we have our combo button open, let's go ahead and get a quick rundown of our controls. The green plus button will let us add different actions to our list. For our non-CMTs, we can choose between 4 different actions: a set bit, delay, set word, or change window. The list itself supports up to 20 consecutive actions and a single delay. The red X is used to delete actions from your list, and by selecting an action and using the arrows on the left side, we can rearrange the order in which our actions will execute. On the bottom, we also have copy and paste functions. And heading to the top, you'll notice our lamp section. One thing that's really nice about our combo button is that, if configured, it can function as either a bit or word lamp as well. Now I like our objects. but the purple background might not be the best fit for our project. Well, I have two choices here. In this scenario, I can either choose a new background color for our project by right-clicking on our work area and selecting Attribute. And in the background section of our Windows Settings menu, I can select a new background color. Let's select gray in this example. And we'll click OK, and our background will reflect the color that we have selected. The second option is to use a static image object as the background of our window. To do this, I'll make sure my Object tab is selected. On the left-hand side of this tab, we'll find our Draw section, and within the Draw section, we'll find our Picture object. I'll select this, and as in our last example, we'll select Picture Library. And I'll search through our Library tab and find a nice system image to use as our background. I'll go ahead and choose a metallic background, and we'll click OK. And then click OK in the Picture object as well. After placing my object, you'll notice I have 8 small blue squares. Using these squares, I can resize my object to fit our display. But in doing so, we covered our bit objects. In scenarios like this, we'll need to use our alignment tools. To use our alignment tools, we'll select our object and then navigate to the Home tab. And in the center, we'll select the icon with 3 layered squares. And in the drop-down menu, we'll select Move to Bottom. Now that we have plenty of experience creating and placing objects, let's learn how to create and navigate to a new window. First, we'll select the View tab on top, and we'll ensure that Window Tree is enabled. With Window Tree enabled, we'll navigate to the bottom left corner and ensure that the Window Tree tab is selected. Then, we'll go ahead and right-click on Window 11, or any unnamed window within your project, and we'll select New to create a new window. And our Windows Settings menu will display. Let's change the name of our window on top. I'll call this window Data. Just as we did before, we can change the Windows background color if we'd like. We can also change the size of this window, which is useful when creating a pop-up window. We have some other functions as well, but because we'll cover this in a bit, I'll keep this simple and we'll go ahead and click OK on the bottom right. Now first, I want to give our new window the same background as our existing window. To do this, we have a very simple method in which we can create and use backgrounds within our project. I'll go ahead and select Window 45 and create another new window. We'll call this window Background and select our gray color. Next, let's open Window 10, select our static picture object, and right-click and select Copy. Now we'll open our background window, and I'll right-click once more and select Paste. Next, I'll right-click on Window 11, and in the Underlay section, I'm going to set our bottom underlay window to our background window. And I think we'll do the same for Window 10 as well. I'll also rename Window 10 to Dashboard, even though there's not much on here. Lastly, I'll delete the metallic background object that we put there, since there is no longer any use for it. Currently, we don't have a way to navigate between our windows, so we'll need to create one. And we'll do this by selecting our function key within the Object tab. By default, our object is configured to change full screen window. However, if later on you would like to experiment, we have some other options in this list as well. The window that we'll change it to is window 11, and this is displayed by default. And I'll go ahead and click OK and place this on the bottom left corner of our screen. Once more, I'll select this object, right click and select copy, and I'll double click on window 11 and right click and then select paste. The object is automatically placed in the correct spot, and if we double click on it to open our function keys settings menu, you'll notice that the window number has automatically changed to window 10. Let's select our new window and we'll create a numeric object. Within the Input section of our Object tab, you'll find our numeric input object. We'll select it. And the configuration is a little different than what we've seen so far. We'll select local HMI within our read address. And let's ensure that in this example, we have LW0 selected. And just to explain, we have a few different local registers within EasyBuilder Pro, but the 4 we'll focus on today are the LWs, which are non-retentive local words, RWs, which are retentive, and LBs, which are the local bits, and we also have LW bits, which are bits within a local word. I'll go ahead and switch to the Format tab. This tab is very important within our numeric objects. This is where we can define the data format of our read address. We can also set limits or customize our character count. Currently, we have our data type listed as 16-bit unsigned, which will be perfect for this example. I'll click OK and place our object. Next, we're going to move forward in our demonstration by discussing data logging. Let's say, for example, that the numeric object that we just placed is reading very important data from an external device. In this scenario, it's likely that the data will need to be recorded for future reference. This is where our Data/History tab comes into play. I'll select this tab, and we'll set up some data logging by selecting the Data Sampling button on the top left. To create a new sampling object within this menu, we'll select New, and our configuration menu will open. Within this menu, let's get an overview of our functions and features. In the comment section, we'll give our sampling object a name. I'll just put Data Sample. The high priority checkbox will ensure that the communication packet has the highest priority among the packets transferred within your project. Data sampling objects can record on a time-based interval as low as 0.1 seconds, or by the change in state of a bit trigger. I'll set our sampling mode to time-based in this example. A single data sampling object can record data from multiple registers. However, in order to do so, the registers must be consecutive, and the read address should reflect the first register within that series. We'll configure our read address as LW0. To define the amount of registers that will be sampled, we'll need to select the Data Format button. Currently, our sampling object is configured to read 0 words of data. You can see this here. Well, within our Data Format menu, I'll select New. In the comments section, we'll give this a name, and I'll name it Data for this example. In my data type drop-down list, I'll select 16-bit unsigned, which corresponds with our numeric object, and I'll click OK in the bottom right. And we'll exit the data format menu and continue setting up our object. Right above the data format button, we can define the max amount of data records that the HMI will save for this specific data sampling object if auto stop is enabled. If it is not, the HMI will save at most 86,400 records per sampling object per day. At the top of the right-hand side, we have a device drop-down list. So the device selected will be the device that is used for the clear real-time data, or hold address, and we'll select our clear real-time data option, with which we can use a bit trigger to clear data within our trend display when in real-time mode. However, data that is already saved within the HMI's history files will not be cleared. I'll set this address to LB1. The hold function will allow us to use a bit trigger to pause data sampling for a specific object, although we won't use this in our example. At the bottom, we can generate and save historical log files to the HMI or an external device. Let's select USB Disk 1. With each file consists of all records in one day selected, the HMI will generate a folder with a user-specified name. The default name is log000. Each data file is named according to the year, month, and day it was created. And if this format doesn't fit the needs of your application, you can instead select Customized File Handling. And this feature will allow you to define a custom name or date format for each file. And it will even allow you to trigger a new data file automatically or manually by defining a bit trigger address. To keep our configuration simple, I'll ensure that each file consists of all records in one day is selected. And I'll set my preservation limit to 1, meaning that aside from the current file being generated today, only one additional file will be saved within our external drive. With my data sampling object complete, I'll click OK and close our settings menu, and then exit our list of data sampling objects. Now we're going to create a few new objects. So in the top left corner, we'll select our trend display. Within our trend displays menu, we have our object index, which is a drop-down list used to select from the various data sampling objects within your project. There are two types of trend displays: real-time and history. Real-time will display data starting from the moment the HMI boots to present. And history mode will allow the trend display to view data from the HMI's historical data files. In this example, we'll leave real-time mode selected, and I'll configure the distance between samples to time, and we can leave this at 100 seconds. We have several additional features below. Enabling dynamic x-axis time range will allow us to configure a word register. In this register, we can enter an alternate time range that will help us control the scaling of our trend display. I'll enable this feature and assign this to register LW1. A hold address is used to prevent the data curve from updating. However, unlike the hold address within our sampling object, the sampling process still continues. Let's go ahead and enable this and address it to register LB2. The watch line will generate a visible line and output data from each curve to a specified register. And our last option is to enable timestamp output. What this will do is output time data to two consecutive 32-bit registers. The first register will display a timestamp associated with the current location of a watch line when selecting a point on the curve, and the second register will display the time associated with the latest data sample. And it's important to note that if you do use this feature, the data will be displayed in seconds. We'll switch to our Trend tab. Here you can configure some of the aesthetics of your trend display. I'll enable Grid in the center, which will give us some horizontal lines that will help us reference points on our graph. I'll also enable Date and Time, which will display a time scale on the bottom of our trend display. And I think this is good enough, so I'll select our Channel tab. Now our Channel tab is very important. All too often, I see mistakes that result in data not being displayed properly. The most common mistake is that high and low limits for a specific channel are not configured correctly. These limits must be configured for each channel individually. And in this example, I'll set my low value to 1 and my high to 10. And while you set this up, you might also consider the pen properties, as it's best to have a unique color for each channel. Before we move on, I'll go ahead and enable Channel Visibility Control. This will allow us to toggle each channel's visibility individually by toggling different bits from within a word register. I'll set our address to LW2. Next, we'll select our Y Scale tab. Here, we can add a vertical scale to our trend display. If you're reading data from several consecutive registers, then each channel will be accessible within this tab, as long as they're enabled. To add a Y scale, I'm going to select our channel under the Y scale column, and clicking once will reveal a drop-down list. I'll select our arrow, and here we can define our Y scale as a main axis or auxiliary axis. The term main and auxiliary refer to where the axis is placed. For our channel, I'll select main axis. And down below, we have some additional options. Similar to channel visibility, we can toggle the bits within a single word register to control the Y scale's visibility for each channel. We'll configure this register to LW3 and demonstrate Y scale visibility. The main axis can also be used dynamically by defining a word register. Within the register, you can enter a specific value associated with the channel's number, which will change the trend display's main axis. And with that configured, we'll click OK and close our settings menu. Now I'll need to create the objects that we'll use within our control address. I'll start by creating a toggle switch addressed to LB1 to clear out our collected data. We'll go ahead and copy this toggle switch, and we'll address this to LB2 for our trend display's hold address. Next, we'll copy the numeric object and address this to LW1 for our dynamic x-axis time range. Well, we still have two more objects to create. We have our channel visibility control and our Y scale visibility. Since these are both word addresses, we'll need to learn how to access and use bits within each word address. Let's copy and paste two toggle switches to start. To access the first bit within our LW2 address, we'll select the Settings button on the right-hand side of our objects menu. And in the address type drop-down list, we'll select LWBit. Down in the address format section, we'll find how to properly address this object. We'll place 4 leading zeros, followed by a 2, to access local word 2. And the first bit is going to be bit 0, so we'll type 00. Following this format, we'll set our second toggle switch as an LW bit, and the address itself will be 0000300, or the first bit within local word 3. And with our trend display configured, let's move on and create a historical data display. Make sure the Data/History tab is selected. And on the left, next to data sampling, you'll find our historical data display object. We'll select this object, and we have a couple settings within our general tab that are very similar to our data trend display. Because of this, I won't focus too much on them. However, at the bottom we have something called History Control. History Control is similar to History Mode in the trend display, which will allow us to select which history file that we'd like to reference within our display. In this demonstration, I'll only be looking at our current data file, so I'll set this to LW4, but I won't be creating a numeric input object for it. Our Data Format tab will allow us to define what channels our history log will display. The Title tab will allow us to give our display captions, which we can also customize. And with my log finished, I'll click OK and place my object. And we'll run an offline simulation. To simulate your project within EasyBuilder Pro, we'll select the File tab in the top left corner and save our project. Next, we'll select the Project tab and click Compile and compile our project. And with this done, we'll click Offline Simulation. We'll test the buttons that we created on our startup window first. Our momentary toggle switch turns LB0 on while we hold our button down, and the combo button turns our bit on for exactly 1 second. We'll use our function key and navigate to the second window within our project. Now this window gives us a lot more control over our data sampling. Our toggle switch will allow us to clear all real-time data, so we can reset our trend display. We can also show or hide the Y scale or curve. And we've created some dynamic control over our x-axis, which allows us to essentially control the horizontal zoom. We have a numeric object that the data sampling object is currently monitoring. Data sampling is a very useful feature to have, but certain situations require additional monitoring. For example, if we were monitoring pressure, there would be a certain limit that could pose danger. In this scenario, it's useful to have the HMI trigger an alarm, which could then notify the operator and potentially even someone remotely. Let's close our simulation and take a look at how to configure this within your project. To get started, we're going to set up our project to generate email push notifications. So we'll select the Home tab and reopen our system parameters. You may or may not have noticed the Email tab within our parameters. We'll select this, and once open, we'll click Enable Email Function. Here, we can configure an SMTP server within our project. This will allow our HMI to send push notifications to an email address or mobile device. It's important to note that you will need to configure your email server to trust third-party applications. In this demonstration, I'm using a Google SMTP server. And if you're not sure how to configure this for your email server, this information can typically be found on the company's website. Within our sender information section, I'll leave the name as local HMI for simplicity, and I'll enter the email address of our server here as well. Now, we'll need to configure some recipients. To do this, I'll click Recipient, and I'll configure my name and email address. Then, I'll select my email configuration and click the right arrow to move my address into Group A. We can have up to 16 groups, although right now we only have one group specified. With our configuration complete, it's always important to test our SMTP settings. Let's go ahead and do so. As you can see, our settings are successful, so let's go ahead and create some alarm push notifications. We'll start by selecting the Data/History tab, and instead of data sampling, we're going to select the Event Alarm Log. The format and settings are actually very similar to our data sampling menu. We'll go ahead and click New. We have a couple of different settings here. We can assign our alarm to a specific category. The categories are used in our alarm display objects. We'll define this alarm's priority as normal. The delay time for event monitoring is used to stop false triggers from occurring during an initial boot sequence. If you've set up your HMI to be controlled remotely through our Easy Access server, then you can also configure push notifications to the Easy Access application as well. In this example, we'll monitor Word data, and we'll set the address to LW0. Now we'll need to define our condition. We'll say our condition is if the value exceeds 5. Next, we'll select our Message tab. At the top, we'll define the content of our message. For this example, I'll put value is too high. The acknowledge value might seem a little confusing, so let me explain this for a minute. An alarm, or each alarm, can be configured with a certain numeric value. When an operator sees this alarm appear in a display object and clicks on it, the acknowledge value will output to a designated acknowledge address. The acknowledge address is typically used by an indirect window. What this will do is display a pop-up warning message that you configure within your project. For our demonstration, we'll configure this to 12 and do just that. We should also take advantage of our multi-watch feature. Multi-watch allows our HMI's alarm message to be dynamic by reading and displaying data from a predefined watch address. Let's change the multi-watch number to 1 and click on the Settings button. Here, we'll configure our watch address to read data from our data input object, which is LW0, and we'll click OK and select our syntax button. Let's copy the syntax for the signed decimal integer, and we'll paste this into our message box. Then change the hash key to 1, as it represents the first watch address. Also, we'll delete the asterisk, as it's not necessary for our syntax. Lastly, let's select the Email tab, and we'll add some push notifications to our project. I'm going to enable a notification when the event is triggered. Next, I'll click on 2, and we'll add Group A to our send list. In our email section, I'll type alarm triggered, and let's go ahead and enable a screenshot of our window, and we'll click OK and exit our alarm properties menu, and our log as well. Now let's create an alarm display object. You can find this object right next to our event log. Within our alarm display object, I'm going to enable our acknowledge function, and I'll address this to LW5. Here, you'll notice that we have something called a scrolling control address. The scrolling control address is used as an alternative to the scroll bars located on the display. This feature will let you enter a number or use some of our set word objects, which we have yet to explore, in order to scroll down a specified number of rows. If we enable this, our scroll bars will remain on the display and show our position, but will not be used for control. Since this feature isn't necessary within our object, I will not be using it today. Within the Alarm tab, we have a couple of different options as far as text color. At default, when an alarm is displayed initially, the text color will be black. Once an operator clicks on and acknowledges the alarm, it will turn yellow. The Sort tab is where we can specify what kind of information we would like our object to display. I'll make sure the event's time, date, and message are selected. And on the right-hand side, I can use the arrows to change our display's order. And I think we're all set. So I'll click OK and place our object. And our screen is getting a little crowded now, so I'll change the size of my other objects as well. Let's get our project ready to use the acknowledge function. To do this, I'll select the Object tab, and we have an object called Embedded Window. Selecting this will reveal a drop-down list in which we can select our indirect window. I'll configure our address to LW5, and we'll place this object in the center of our screen. And I'll also make it a little bit bigger by adjusting the size. Now within our window tree, let's create a new window on window 12. I'll call this window Alarm Message. I'm going to change our height to 200 and width to 300. Let's give our window a dark color so it stands out. And we can click OK and then double click on our window to open it. We'll give our window a message. In our Object tab, we'll select the A button in the Draw section to create a static text object. In our object, I'll type, "Please lower the input value." And we'll make our text white. To close this window, since it's an indirect window, meaning that the window displayed is based on the value entered within the indirect window's address. We'll need to enter a 0 into LW5. So we'll create a setWord object by selecting the setWord button in our Object tab. We'll address this to LW5 and leave our constant value at 0. Let's also select the Label tab and create a label for this button. We'll enable Use Label, and I'll label this Close. And we'll duplicate the label in the label's settings to each state and place our object. With everything configured, let's go ahead and run another simulation. This time, let's go to our File tab. Within the drop-down menu, we'll select Preferences, and let's ensure that Automatically Save and Compile Project is enabled. I'll click OK, select the Project tab, and click Offline Simulation. And we'll switch to our second window. As you'll recall, the alarm will trigger for any value greater than 5. So let's enter 6 to trigger this alarm. And the alarm shows up in our alarm display object. And let's say that I'm the operator in this scenario. I'm wondering what triggered this alarm and how to resolve it. So I'll click on this. And clicking on our alarm will acknowledge it and submit the acknowledge value of 12 to register LW5. This register is used by the indirect window to display a pop-up message which contains instructions on how to correct this alarm. So I'll close this indirect window using our setWord button, and let's lower the value to 5. Since the value of our input address is no longer greater than 5, the alarm is resolved and the message is cleared. Also, you might have noticed that I received an email when our alarm was triggered. Let's take a look at the content of our push notification. The subject is the title of our message. The body is what we defined within our opening description. And we have some details about our alarm. We also have a screenshot attached, which shows us what our display looked like when the alarm took place. Let's close our email and simulation. And next, I'd like to discuss our event display object. In most scenarios, the alarm display object will probably provide sufficient information and control. But some situations may require more than this object can provide. Let's delete our alarm display, and then we'll select the event display object instead. On top, we have two different display modes. Real time will display all events since the HMI's boot sequence. And history will allow you to display alarms from the HMI's historical log files. We'll keep real time selected in this example. Just as before, you'll notice we can configure an acknowledge address. And I'd like to point out that if I select history mode instead, the acknowledge address turns into a history control address, which we can use to change what historical log file is referenced. With either mode selected, we can also configure a scrolling control address or enable an event management address. With this enabled, we can submit commands to a user-defined register. The commands are defined and displayed within a separate menu accessible when clicking the usage button. The controls allow us to configure what type of events are displayed. For example, if I want to hide any events that have been recovered already, I would ensure that a value of 2 is entered within the control address. When in real-time mode, I can also delete certain selected events by entering a 1 into our second control address. For this demonstration, let's define our control address as LW6, which will give us a second control address of LW7 as well. Selecting the Event Display tab, we have a few additional options that were not available within the first display object. As an example, we can now configure the Return to Normal color. And two things that I forgot to point out within our first object are the Include Categories section and the Acknowledge Style section. If you can recall, we have assigned our alarm to category 0, meaning that within this object, if we chose to include only categories 1 through 255, our alarm would still be triggered but would not display. The Acknowledge Style setting, located in the top right corner, will allow you to decide if an operator must click or double-click an alarm to acknowledge it. Switching to the Sort tab, we'll find that we have 3 additional options. However, for simplicity, we'll stick with the time, date, and message of our event. The last tab that we'll take a look at today is our Empty Warning tab. What this will do is fill the display with a pre-configured comment that will display when there are no events triggered. I'll enable Use Empty Warning, and I'll type No Active Alarms. With that finished, let's click OK and close our window. And we'll place our object in the same spot as before. We should also create our LW6 and LW7 numeric control objects. To do this quickly, we'll copy our existing numeric objects and change the read address accordingly. Before we run another simulation, let's head back to Window 10. I'm going to create a new function key, and because our project is built with Use Template selected, we have some very useful pre-configured windows. I'm going to assign our function key to Windows 78, the Contact Editor window. I'll add a label for this button as well. The Contact Editor window will allow us to add, remove, and edit email contacts after the program has already been downloaded to the device. The window itself contains everything necessary to get started. Let's take a look at the Contact Editor's configuration. We have 3 control registers, the first being our command register. This register is used to perform the following functions. The second register isn't necessarily a control register, it's actually used to provide feedback after a command is executed. The third register is used to define and update what groups a contact is associated with. These are referenced by accessing the individual bits within a word register, just as we did within our trend display. Our contact editor then utilizes 64 words of data for the ASCII objects used to define the name and address of each contact. We have a few additional tabs that allow you to customize the editor, but we're going to actually close this and take a look at the ASCII object. Now, so far, I haven't had a chance to introduce the ASCII object. These objects, which can be found next to the Numeric object within the Input section of the Object tab, are used to read and write string data. ASCII objects support multi-line display, input masking, and reversal of the high and low bytes, as well as Unicode format. Next to our ASCII objects, we have something called an option list. In this template, it's used to execute commands within our contact editor, but the option list can actually do so much more. As an example, this object on our non-CMTs has the ability to directly interact with our HMI's historical data logs. Although currently it's configured to use a predefined list of commands, each associated with a different numerical value, mapped to the description within our Mapping tab. And the objects that allow us to assign a specific contact to a group are toggle switches, which of course we've already mastered early on in this demonstration. If you'd like to use our contact editor and don't care for the pre-configured window, this object can be found in our Object tab as well, right next to the Action Trigger object. Now, let's head to our Project tab and run another offline simulation. I'll switch windows, and we'll take a look at our Event Display object first. The empty warning is visible right away, and in an object with this much control, it's definitely a nice feature to have. Let's go ahead and trigger our alarm. With the alarm triggered, our display changes, and of course I also get my email. Let's select our alarm, and our acknowledge window displays. The alarm text turns yellow, which tells us that the alarm has been acknowledged. Now if we change our value to 4, which is below the condition value of 5, our text turns green, which lets us know that the alarm has been resolved. Now let's say that since this alarm was resolved, we don't want to see it any longer. So we'll go ahead and enter a 2 into our first control address. And you'll see that our resolved alarm disappears. I'll reset our control address to 0 and select our alarm. And then we'll use our second control address and enter a 1 to delete the alarm. And I'll switch back to our dashboard so that we can access our contact editor. Let's say that we wanted to add Bob into our contact list. I'll type in his name, and then we'll add his email, bob@mail.com. And I'll submit our add command, and you'll notice that Bob was added to our contact list. Now I should probably assign him to a group. To do this, I'll select Bob, and then click Group A, and I'll select Add to Group. Unfortunately, the number of groups are specified within the system parameters and cannot be changed dynamically. And since we've only specified one group, we can only assign contacts to Group A during this demonstration. Let's close this simulation and move on to the next topic. We'll need to ensure that our project tab is still selected. And this time we'll open our address library. The address library is used to reference both system tags and user-defined tags. And I'd like to clarify that tags imported from an external source will not be displayed within this section. Instead, the UDT section of our address library is used to create custom tag names for registers within an external device or for the HMI's internal registers. System tags, on the other hand, are used to control functions on the HMI. A good example of this can be found within Section 4 of our local HMI network information section. These registers can be used to update the HMI's network settings, which will allow you to make network changes on the HMI without accessing the HMI's settings menu. Let's close our address library and take a look at how we might add this into our project. We'll select Window 10 for this example and select our Object tab. Once there, we'll select a numeric object. Next to the read and write address, we'll select Settings. And in our pop-up menu, I'll change my device to local HMI. Down below, you'll notice we have a system tag checkbox. Let's go ahead and select this. Now our address type drop-down list will allow us to search for and select the various system tags available within our project. And I'd like to point out that the settings menu is available within other objects as well. In this example, we'll select Section 4 and choose our HMI's LAN 1 IP, which is register LW9129. Then I'll click OK and we'll place our object. Now, we actually need 4 separate objects to configure our HMI's LAN 1 IP. I could go through and create each object by hand, but that can be tedious if I need to create several sequential objects. An easier way to do this is to select our numeric object and then right-click and select multi-copy. We can control the spacing on top, and more importantly, towards the center, I'll select 4 objects in the X direction and 1 in the Y. This will create 4 objects. On the bottom, we'll configure the address offset to 1, which will automatically adjust the address of each object. And we'll select OK on the bottom right. And as you'll notice, we now have all 4 numeric objects associated with our LAN 1 IP. Because our demonstration has placed a large focus on data logging, I feel that we should also add in some additional control by using our system tags. Let's create a toggle switch. And we'll open up our settings menu so that we can search through our system tags. In our event log section, I'll select LB9021, which will reset our event log data. And I'll set our switch style to momentary and click OK and place our object. Now the last part of this project involves our macro workspace. We'll begin by making sure our project tab is selected. And within this tab, let's go ahead and click macro. This will open our macro manager. And to create a new macro, we'll select new on the top right. I'll give our macro a name. I'll name this data log details. Now, macros can be used to perform many different functions. Using logic, They can be scripted to monitor and control a device based on specific conditions. But within our macro, our main function will be to search for data sampling files. Let's get started by declaring some variables. First, we'll define a short, and our first variable will be called sample. Next, I'll type index, and then year, month, and date. Also notice that I've placed a comma in between each variable. Then, on the next line, we'll define a bool variable, and we'll call this verify. I'll select enter a couple of times to separate our functions from our variables. Down on the bottom left, we'll select the get/set button. This will bring up our built-in macro function menu. Within the function name drop-down list, I'm going to select get data at the bottom. We'll leave the variable as our sample variable, and I'll define the address as LW8 and click OK. Next, we'll copy our getData command and paste it on the line below. I'll change our variable's name to index and the address to LW9. On the next line, I'm going to type verify equals, and then I'll select our get/set button once more. This time, we'll define our category as data/event log. And we'll go with the first function, find data sampling date. The first variable will be sample, and the second will be index. And we'll click OK and place our function. One of the built-in functions within our macro function manager is called setData. I'll show you how to access this first, and then we'll take a look at a shortcut. Let's reopen our API function manager. And we'll select the function name drop-down list. And we'll scroll down. It's organized alphabetically, and we'll find this towards the middle. But instead of selecting this here, we'll go ahead and close our menu. And I'm going to repaste the getData function that we copied earlier. I'll do this 4 times. The nice thing about our macro workspace is that since this is text, we can modify our functions very quickly. Let's change our G's to S's, and I'll change our variables to verify, year, month, and day. And I'll address the verify variable to LB3, and our year, month, and day variable to LW 10, 11, and 12. On the bottom right, I'll select Save and Compile. And you should see 0 errors and 0 warnings in the dialog box at the bottom. And since that's the case, we'll select Exit. And back on our work area, we'll select the Object tab once more. I'll create a numeric object addressed to LW8 and place this object. We'll use our handy multi-copy and create 5 copies with an offset of 1. And I'll copy the bit lamp on our dashboard as well and readdress this to LB3. Last but not least, I'll create a new function key. And in our configuration, I'll select Execute Macro. And by default, our macro is automatically selected. I'll click OK and close our function key, and we'll run one last simulation. On our dashboard, we have our new objects. The first two numeric objects will allow us to identify the data log number and index. By data log number, I'm actually referring to the data sampling object number within your list of data sampling objects. The index number is used to determine what file is referenced from that object. In our project, the number associated with our data sampling object is 1, because it's the first data sampling object. And to target the first file, we'll leave our index object at 0. And we'll click our function key to trigger our macro. And the most recent date for the data sampling file will appear in the numeric objects. And using the second numeric object, we'll change our index to 1, and I'll select our function key once more. And the date of our second file is shown here. Now let's navigate to our alarm section and trigger our alarm a couple of times. And with a few items in our event log, we'll head back to our dashboard and test our system bit. And you'll notice our event log is now empty. And our empty warning is displayed. With that said, I hope you've learned a lot from this in-depth lesson with EasyBuilder Pro. And as always, if you found this tutorial helpful and would like to see more, head on over to our YouTube channel and select the playlist tab. Feel free to check out our website as well for free demo projects, user manuals, and more. Thank you for watching.